Now let's solve a relatively simple parallel circuit. The current that leaves the battery will flow in this direction and branch into 3 separate values before rejoining and returning to the battery. So we'll label each current. This will be current value 1, current 2, current 3, and this will be a total current. The total current returns back into the battery. This means that only a fraction of the current that leaves the battery passes through resistor 1. A different fraction passes through resistor 2, and finally a third fraction through resistor 3. Let's first use Ohm's law to find the total resistance. I'm sorry, I misspoke, not Ohm's law. Let's use the rules of parallel resistors. Let's see. 100 ohms, 200 ohms, and 300 ohms. Let's write all that down first. I don't want to lose anything. Total resistance value is 54.5 ohms. Now let's discuss the voltage drop as we cross resistor 1. If you were to measure voltage here and here, you would measure 1.5 volts. The total voltage drop is 1.5 volts. The voltage drop through resistor 1, 1.5 volts. This is because each end of resistor 1, 2, and 3 are connected directly to the terminals of the battery that have a voltage of 1.5 volts. So the current, let's now find the total current. Recall Ohm's law, solving for I. The voltage drop for the battery, 1.5 volts. The total resistance of my circuit, approximately 54.5 ohms. .028 amps. This will be the total current value. Let's now find the fraction of the current that flows through resistor 1. .015 amps. The current flowing through resistor 2, 0.0075 amps. And again, like in the previous example, the sum of these three currents should give us the total value. And I get 0.0275. Simply not accurate.